Rapid and systematic house construction using prefabricated techniques. The construction of a house using prefabricated materials and modern techniques has revolutionized the building industry. These approaches, often referred to as modular or prefab construction, allow for rapid, efficient, and high-quality results while maintaining precision and durability. This method relies heavily on pre-manufactured components that are transported to the site for quick assembly. Let us explore this process through a detailed 10-day timeline, as demonstrated by the time-lapse construction of a home by Grootesbouw Emmeloord in Maasbracht. Day 1. Foundation work. The first day focused on laying the foundation, a critical step in any construction project. The foundation was placed on pre-installed piles, providing stability for the structure. Afterward, floor slabs were installed, creating a sturdy base for the house. Simultaneously, the sewer system was laid, preparing for essential utilities. Prefabrication ensures that these components are precisely engineered, reducing the time spent on-site and guaranteeing a robust start to the project. Day 2. Ground backfilling. On the second day, the sewer system installed on day 1 was connected. This was followed by backfilling the ground around the foundation. Backfilling provides structural support to the foundation and prepares the site for further construction by leveling the surrounding terrain. This stage also ensures proper drainage, crucial for long-term stability and to prevent water damage. Day 3. Sand lime brick bonding. Day 1. With the foundation solidly in place and the site prepared, the focus of construction shifted to erecting the house's walls. Sand lime bricks were chosen for this phase due to their exceptional strength, precision, and thermal efficiency. These bricks are made from a mix of sand, lime, and water, which is pressed and hardened in an autoclave. The result is a dense, robust material ideal for constructing load-bearing walls that meet modern standards for durability and insulation. On this first day of wall construction, a base layer, known as the Kim layer, was carefully applied to ensure a level and stable foundation for the walls. This layer is crucial as it provides the alignment and stability necessary for the brickwork to progress smoothly. The construction team then began bonding the sand lime bricks. Unlike traditional mortar techniques, this method often uses a thin bed adhesive that allows for precise placement of the bricks. Day 4. Sand lime brick bonding. Day 2 and scaffolding installation. On the fourth day, construction advanced with the completion of the load-bearing walls using sand lime bricks. Building on the progress from day 3, the remaining bricks were carefully bonded to finalize the structural framework of the house. The precision and uniformity of the sand lime bricks, along with the use of thin bed adhesive, allowed the walls to be assembled efficiently while maintaining a high degree of accuracy and strength. Each brick was meticulously aligned to ensure a sturdy and durable framework, capable of supporting the subsequent stages of construction. In parallel with the wall completion, scaffolding was installed around the building. Scaffolding is a crucial component for multi-stage construction, providing safe and stable access for workers during tasks like roofing, masonry, and external finishing. The prefabrication approach ensured that the scaffolding was quickly and securely set up, aligning with the project's fast-paced timeline. This dual progress, finalizing the walls and installing scaffolding, underscored the efficiency of modular construction techniques. Day 5 marked a major milestone in the construction process, highlighting the unparalleled speed and efficiency of modular construction techniques. The focus of the day was on assembling the house's first-floor structural elements and upper-level framework. The first-floor slab, a prefabricated concrete component, was lifted into place with precision, creating a strong and level surface for the upper story. This step, which would typically require extensive formwork and curing time in traditional methods, was completed in mere hours thanks to prefabrication. Following the slab installation, attention turned to the exterior features. Pre-made gutters were affixed, ensuring proper drainage and protecting the building from water damage. Window frames, manufactured to exact specifications, were installed with ease, fitting seamlessly into their designated spaces. The roof ridges, which form the apex of the roof structure, were then positioned to outline the final shape of the building. The most impressive achievement of the day was the assembly of the upper floor walls, made possible by the modular nature of the prefabricated panels. These walls, already prepared with precision off-site, were erected swiftly and securely. The sixth day of construction marked a significant leap forward as the focus shifted to completing the roof structure and beginning interior installations. Pre-assembled roof panels were lifted into place with precision, creating a secure and stable top for the house. These panels, constructed off-site to exact specifications, minimized on-site labor and reduced the chance of errors. Their installation was completed efficiently, showcasing the advantages of modular construction. Alongside the roof panels, other key elements of the roofing system were integrated. Roof windows and dormers, designed to enhance natural lighting and ventilation in the upper levels, were securely mounted. The chimneys, another vital feature, were positioned with ease, thanks to their prefabricated design. These components not only added functionality, but also contributed to the house's visual appeal. Inside the house, parallel progress was made as the plumber and electrician began installing technical systems. Plumbing pipes, electrical wiring, and other essential networks were integrated into the structure seamlessly, facilitated by the precision-engineered design of the house. The concurrent execution of multiple tasks, roofing, interior systems, and structural assembly, highlighted the streamlined workflow of modular construction, ensuring the project remained on schedule while maintaining quality. On the seventh day, the focus shifted to the final stages of roofing as black roof tiles were installed. These tiles served both functional and aesthetic purposes, providing critical protection against the elements while complementing the modern design of the house. The sleek black color added a stylish and contemporary touch to the structure. Despite the challenge of completing this work on what was perhaps the hottest day of the year, the team's efficiency and use of prefabricated methods ensured the project remained on schedule. The tiles, prepared for easy assembly, were laid out systematically, creating a uniform and secure covering for the roof. This streamlined approach not only reduced labor time, but also ensured the roof was weather-tight by the day's end. Simultaneously, work progressed inside the house. The team began installing gypsum boards on battens to cover the interior walls and ceilings. This process is a key step in preparing the surfaces for plastering, which will eventually create smooth and finished interiors. On the eighth day, the focus shifted to energy efficiency and sustainability. Insulation materials were applied to the house's walls and roof to regulate internal temperatures and reduce energy consumption. Additionally, the structure was sealed to make it airtight, preventing drafts and ensuring a higher level of thermal efficiency. These measures are essential for modern homes, which aim to meet stringent energy efficiency standards. The precision of prefab components enhances the effectiveness of these installations, ensuring no gaps or flaws. With the main structure of the house completed, Day 9 marked the beginning of the exterior masonry work. Focusing on the front and side walls, masonry is an essential step in giving the house its final appearance while reinforcing its structural integrity. Using high-quality pre-cut bricks, the team methodically laid them in carefully planned patterns, ensuring consistency and a polished finish. The prefabrication of materials played a crucial role in expediting the process. Each brick was precision engineered to fit seamlessly, minimizing adjustments and ensuring straight, uniform walls. The use of advanced bonding techniques, such as thin bed mortar or specialized adhesives, further enhanced efficiency by reducing curing time and waste. This phase of construction was as much about aesthetics as it was about durability. The carefully chosen brickwork added texture, color, and character to the facade, creating a striking visual impact. Additionally, the brick layer provided extra insulation and weather protection, enhancing the overall energy efficiency and longevity of the house. The 10th and final day of the main construction process concentrated on detailed masonry work, particularly around the roof ridge. This stage was critical, as the roof ridge serves as a key structural element, while also being a prominent visual feature of the house's exterior. Achieving both durability and aesthetic refinement required meticulous craftsmanship and precision. The focus was on applying intricate brick patterns that enhanced the architectural character of the house. These patterns not only added elegance, but also demonstrated the versatility of prefabricated bricks, which were precision-cut and prepared off-site to ensure consistency and ease of installation. Skilled masons worked carefully to position each brick with accuracy, ensuring that the design was cohesive and aligned with the overall look of the house. Prefabrication once again played a pivotal role in streamlining the process. The pre-designed and engineered materials allowed the team to complete this intricate work efficiently without sacrificing quality. By the end of the day, the exterior brickwork, including the roof ridge details, was fully completed. Earthbag building is a sustainable construction method that utilizes bags filled with earth, typically soil and sometimes mixed with sand or gravel. This technique, which hails from ancient practices, has gained significant attention in recent years due to its environmental benefits, affordability, and versatility. The time-lapse of an Earthbag building project offers a fascinating visual journey, showcasing the rapid transformation of raw materials into a sturdy, functional structure. At the heart of Earthbag construction is the use of polypropylene bags filled with earth or other locally available materials, such as clay, gravel, or sand. The bags are stacked in rows and tamped down to form solid walls. Barbed wire or metal mesh is often placed between the layers of bags to help secure the walls and increase their strength. The building process begins with a well-prepared foundation. Often, a trench is dug around the building's perimeter to create a stable base, sometimes filled with gravel or stone for drainage. The time-lapse of this stage reveals the careful excavation process, highlighting the importance of a strong foundation for the longevity of the structure. Once the foundation is in place, the first layer of bags is laid. The time-lapse begins to capture the rhythm of workers efficiently filling the bags with earth and placing them on the foundation. Each bag is carefully positioned and tamped down to ensure the structure is level. Barbed wire is placed between layers to bind them together, and each additional layer builds upon the previous one, creating the walls of the building. The time-lapse showcases the gradual shaping of the building. Earthbag construction is highly flexible and can accommodate various shapes, including straight walls, curves, and domes. As the walls rise, the shape of the building begins to take form, often with a sense of organic fluidity. The design of the structure is one of the most appealing aspects of Earthbag construction, as it allows for an intuitive, hands-on approach to architecture. In some projects, Earthbag buildings feature domed roofs, which are especially effective for thermal mass, keeping the interior temperature stable and comfortable. The time-lapse may highlight the gradual arching of the roof or the addition of a vaulted ceiling, depending on the design. The beauty of an Earthbag building is not just in its functionality, but also its connection to the environment. Many Earthbag buildings are designed to blend seamlessly into their surroundings, using local materials and harmonizing with the landscape. The time-lapse will often capture the surrounding environment as the building rises from the earth, making the construction process feel like a natural extension of the landscape itself. As the walls of the Earthbag structure are built, spaces for windows and doors are left open. These gaps are carefully framed with wood or metal, and the time-lapse can capture the installation of these components, which are critical for ensuring that the building is both functional and livable. The addition of windows and doors brings a sense of light and airiness to the building, and as the structure nears completion, the time-lapse may show the installation of roofing, final plastering, or other finishing details that help to seal and protect the structure. One of the key benefits of Earthbag building is the ability to finish the walls with natural materials. Plaster made from clay, lime, or other eco-friendly materials is often applied to the walls, helping to smooth the surface and provide additional protection against the elements. In the time-lapse, this step might show workers applying multiple layers of plaster, with each coat creating a smooth, durable finish that contributes to the building's overall aesthetic and functionality. Time-lapse photography, by speeding up the construction process, provides a unique perspective on the Earthbag building journey. It compresses days, weeks, or even months of work into just a few minutes, allowing viewers to appreciate the steady progress of the project in a short span of time. Watching a building rise from the ground, layer by layer, offers a sense of accomplishment and demonstrates the potential of sustainable construction methods. Additionally, time-lapse videos often show the changes in the surrounding environment over time. Changes in weather, shifts in lighting, and the natural growth of nearby vegetation can add depth to the narrative of the building's construction, reinforcing the idea that Earthbag buildings are a part of the land rather than separate from it. The first step in building a wooden attic is to frame the roof. This includes constructing the trusses or rafters, which form the support for the roof. The trusses are made from strong wood beams, typically pine or other softwoods, and are spaced evenly across the width of the building. These trusses provide the necessary support for the attic's floor and roof, distributing the weight evenly. Once the roof trusses are in place, the next step is to install the floor joists for the attic. These wooden beams are laid perpendicular to the trusses and spaced at regular intervals. Floor joists are usually made from dimensional lumber, such as 2x6 or 2x8 boards, and they create a solid foundation for the attic floor. The joists are secured to the walls of the building, ensuring they remain stable and capable of bearing weight. After the joists are in place, the next step is to cover the attic floor with plywood or oriented strand board, OSB. This provides a solid, walkable surface and prepares the attic for insulation, storage, or further finishing. The plywood is nailed or screwed into the floor joists, securing it tightly in place. Finally, the roof decking, such as plywood or OSB, is installed on top of the trusses. The roof is then covered with roofing felt, shingles, or metal panels. Insulation is added between the rafters to regulate temperature and improve energy efficiency. This insulation is often fiberglass or spray foam.
One of the most striking aspects of the NewArk Hotel is its earthquake resistance. The building employs a diagonal bracing structure made from lightweight steel, which not only enhances stability but also passed rigorous Level 9 earthquake resistance testing. This makes it a highly secure structure, capable of withstanding significant seismic activity. The materials used in the construction are much lighter compared to traditional methods. At just 250 kilograms per square meter, the materials are 6 times lighter than conventional alternatives, which often exceed 1,500 kilograms per square meter. Despite this, the walls and floors remain solid, offering airtight, soundproof environments without compromising safety or durability. Energy efficiency is another key feature of the NewArk Hotel. The building is designed to be 5 times more energy efficient, incorporating 150 millimeters thermal insulation for the walls and roofs, triple glazed windows, and solar shading on the exterior. These features, combined with heat insulation, fresh air heat recovery, and LED lighting, ensure that the hotel uses a minimal amount of energy. Its annual HVAC AC energy consumption is equivalent to just 7 liters of oil. The NewArk Hotel also stands out for its air purification system, which undergoes 3 levels of purification, resulting in fresh air that is 20 times cleaner than outdoor air. The purification efficiency reaches between 95% and 99.9%, and air is exchanged 1 to 2.5 times per hour, ensuring a constant supply of fresh, clean air for occupants.